Hello everyone, Miss Scott here, and today we are going to cover the midpoint and distance formulas. And we'll be using these quite a bit throughout the year, and you also use them in Algebra 2, so this is an important lesson. So our essential question today is actually two questions. The first one being, how do you calculate midpoint, and how do you calculate distance? Well, first we need to talk about what midpoint is. Midpoint, as you can probably guess from the term, is the halfway point of a segment. Alright, so it's right in the middle of a segment. So if you want a little sketch of what a midpoint is, say you have a segment here, then right in the middle, which would cut this into two equal pieces, that would be the midpoint. Now, a segment bisector is a line that goes through the midpoint. Goes through the midpoint. Alright, so again, if we have a sketch here of a segment, and we've got the midpoint here, then the segment bisector would just be a line that goes right through that midpoint. Alright, so now we're going to use the idea of midpoint to solve a couple of algebraic problems. The first one says, find the length of segment DE. Well, in order to figure out the length of this entire segment, we need to know what x is. Notice that M here is the midpoint because this segment DM is the same length as this segment ME. Well, what that means is that we can set this expression 5x minus 6 equal to 2x plus 5. And from here we just use algebra to solve. So let's subtract 2x from both sides to get all of our x's on one side. We end up with 3x minus 6 equals 5. And I'm going to add 6 to both sides. So these cancel. I end up with 3x equals 11. And if I divide by 3, these cancel, and I end up with x equals 11 thirds, or about 3.67 if you divide 11 by 3. But again, be careful because it's not saying find the value of x, it's saying find the length of segment DE. So the very last thing is let's plug x in here. So we have 2 times 3.67 plus 5. And if you plug that into a calculator, you end up with about 12.34. So that means this distance is 12.34, this distance is 12.34, so DE would be both of those added up, and that is 24.68 units for the entire length. Okay, let's try another one. If you feel like you got number 1, if you'd like to pause and give number 2 a try on yourself, or try by yourself, go ahead and do that. But we'll jump right in. So they tell us to identify the segment bisector of PQ first of all. Well, notice this line L goes through the midpoint of segment PQ, cutting it into these two congruent pieces. So the first part of the question, we would just say line L is the segment bisector. Then we're going to use some algebra skills here to find the length of PQ. Alright, so first of all, we can set up an equation very similar to what we did in example 1. 5x minus 7 equals 11 minus 2x. I'm going to get rid of this minus 2x by adding it to both sides here. These cancel. And we end up with 7x minus 7 equals 11. Go ahead and add 7 to both sides. These 7's cancel on the left. We end up with 7x equals 18. And if we divide both sides by 7, we end up with x is about 2.6. All right, and again, we have not quite finished yet because we're asked to find the length of PQ. So I'm gonna plug into this expression. Now I know that x is 2.6, so 5 times 2.6 minus 7. If you go ahead and calculate that, you end up with, from P to M, that segment's length is 6. So the entire length, this is 6 and this is 6, PQ has to be 12. All right, so some good practice of those algebra skills. Well, now we're going to see how we can actually calculate where that midpoint is if we know where 2 points are on a graph. So this formula is telling us we add the x coordinates and divide by 2, and then we add the y coordinates and divide by 2. The midpoint is kind of like the average of the two endpoints, you can think of it as. So when you see these x1s and x2s and y1s and y2s, the x1 and y1 are just your first x and y value. And likewise, the x2 and y2 are your second x and y value. So we're going to take the average of the x's, which in this case is 4 and 6, so add them up, divide by 2. Do the same thing with your y's, add them up, divide by 2, and that'll give us our midpoint. So here we've got 6 plus 4 is 10 divided by 2, and negative 1 plus 0 is negative 1 divided by 2. So we end up with 10 divided by 2 is 5, comma, and we can't divide negative 1 by 2, so we will just leave that as negative 1/2. So this would be right in the middle of points S and T. Okay, let's try another example here. Now we're given a graph. We're going to find the middle of S and T again, but now they are in different places. So first off, let's add the x values, negative 2 and 5, divide by 2. And add the y value, 0 plus negative 4, and divide by 2. All right, so negative 2 plus 5 is 3 divided by 2. 0 plus negative 4 is negative 4 divided by 2. So our midpoint ends up being 3 divided by 2 is 1.5 or 1.5. Negative 4 divided by 2 is negative 2. And if we put that point on the graph, if we go over 1.5 and down 2, we'd end up right there. And just by looking at our graph we have, that does appear to be right in the middle, so it looks like we did a good job. Okay, now example 5 is going to get a little bit trickier. We're going to find the coordinates of endpoint S of segment RS if we know where R is and we know where the midpoint is. So I'm going to draw a sketch of this. I'm going to separate this into the X's, and then I'm going to draw another picture for the Y's. So we have this segment RS. So here's R, here's S, and let's call the midpoint M. Well, what they tell us is that R, actually let's switch this up because I noticed that the midpoint is actually less than R. So we'll put R over here, and then we'll go back to M, and we'll figure out where S is. So R's X coordinate is at 11, and the midpoint's X coordinate is at negative 4. Well, if you start at 11 and then go down to negative 4, that's a difference of 15. So this is 15 units away from R, meaning M and S also have to be 15 units away. So if we go down 15 more, negative 4 minus 15 is negative 19. So we've got, for point S, the X coordinate is negative 19. Now let's do the same thing with the y's. So here is point S. Way down here we'll put point R, and right in the middle we have the midpoint. So now we're looking at the y coordinates. The y coordinate of R is at -5. The y coordinate of the midpoint is at -4. So if we start at -5 and go up to -4, we go up 1. So if we go up 1 more, well, -4 plus 1 is -3. So the y coordinate of endpoint S is at -3. All right, so that's more of a visual way of figuring out where the other endpoint is. If you, on your assignment, don't like this strategy, what you can do is there is a QR code on your assignment that you can scan, and that will give you a more algebraic way of solving this. So if this didn't go well for you, use that QR code and watch an algebraic example very similar to this one. All right, our last topic is the distance formula. So let's go ahead and jot that down. If you want to find the distance, which we usually call D, of 2 points, you subtract the x coordinates. So you take the difference of the x's, square it, and then the difference of the y values, square it, and then you take the square root of the whole thing at the very end. I know this formula looks like a little bit overwhelming, but let's put it into practice. So example 6, we're going to find the distance of the segment with these given endpoints S and T. And let's go ahead and plug in. So if you like to label, you can. This is your x1 and y1 and your x2 and y2. So our formula tells us first to subtract the x values. So our second x value is 5. Our first one is -2. So we have 5 minus -2 squared. And then our y values, our second y value is -4. And our first one is 0. And then we square that. And then we take the square root of the whole thing at the end. All right. So 5 minus -2 is actually 5 plus 2, which is 7 squared. -4 minus 0 is -4 squared. And then we take the square root of that. So we've got 49 plus -4 squared is -4 times -4, which is positive 16. And we end up with the square root of 65, which is about 8.1. All right. Again, like what we did with the midpoint formula, if you'd like to give example 7 a try on your own, you can pause and then fast forward to see if you got it right. Otherwise, we are going to go through it right now. So let's label our first x and our first y, second x and second y. All right, so if we plug into the formula, we have 6 minus 4, our x's, and that's squared, plus the difference in our y's, 0 minus -1 squared, and we take the square root of the whole thing. So 6 minus 4 is 2 squared, plus 0 minus -1 is like 0 plus 1 squared. So 2 squared is 2 times 2. 1 squared is 1 times 1, which is 1. And we end up with the square root of 5, which is approximately equal to 2.2. Okay, so there's a couple of examples of using that distance formula. All right, so that is how to use the midpoint and distance formulas. If you have any questions, please don't hesitate to ask. Again, I would much appreciate it if you would subscribe to my channel. Enjoy the rest of your day or night or morning, and I will see you next time.